Hello, welcome back. Last time we were here, I talked about the binary operators, the arithmetic operators, and I told you we were going to cover the unary operators in part 2, which is what we're going to do now. We're also going to cover the math library functions, and we're also going to cover a little bit of the string functions, which have manipulation of character strings. Now, let's go over the unary operators. First one is the unary minus. Okay, that just negates a number. So for example, if I say int my value, and I do cout my value, I can do this, and that just basically will negate the value 5, where I can say minus that plus 10 times 2. Okay, so what that's going to do is it's going to turn this into a negative 5, but you have to remember we're talking about precedence, and we're also talking about associativity. The precedence here comes into play because multiplication goes before addition. Okay? But you also have to pay attention, because you're dealing with an operator, which one goes first with the unary operators. Well, let's look at our chart. Okay, and what I mean is by the negation sign. The negation sign looks like will go first, and then the multiplication, which is 6, and then the addition. Okay, so what's going to happen with this expression, the way it's going to be evaluated, is it's going to first negate my value to negative 5, and then it'll do 10 times 2 plus negative 5, which would give you, that's 10 times 2 would be 20, 20 plus negative 5 would be 15, right? So let's try that, and there you go. You have the value of 15. Okay, let me backtrack a little bit. This unary minus is still considered an operator. Because it's unary, it only acts upon one operand. In this particular case, it would be this one operand. Okay. For example, another example I can give you is your unary operand could be something like this. Okay. So what do you think is going to happen here? Well, what goes first? Parentheses will always go first. So this will get evaluated, right? 5 times 2 is 10. Then it'll negate it, so it'll be negative 10. But now you have multiplication, which will give you 10 times 2 will be 20. 20 plus negative 10 will give you 10. And there you go. Okay, but again, you have to pay attention to the order of precedence as well as the associativity. Now, again, let me repeat this. This is considered one operand because this first needs to be evaluated to one value. This isn't a combination of two operands. It's one operand because it's in parentheses. So again, this is a unary operator. The unary operator can only act upon one operand. Okay? But that one operand could be a combination or an expression of operators and operands, as long as the remaining value or the result of the combination will result in one operand. Okay? Okay, next is we'll cover typecast, which gets one operand, size of, which gets one operand. We went over the unary minus, the increment, and the decrement. Okay. Again, I repeat, binary operators have two operands. Unary operators have only one operand. So let's go over typecast. Typecast changes the data to another data type. But when you use a typecast, you're not permanently changing the data. You're only changing it at the time that you're using the typecast. And there's two types of typecasting. There's implicit casting and there's explicit casting. Implicit casting is done automatically by the compiler. Explicit casting is done by the programmer, or it's programmed. When I explicitly cast a variable, that means I am using the typecast operator in my expression. But when the compiler implicitly casts a variable, or it could be a literal, then that means that the compiler is handling it and I haven't done anything programmatically to do a typecast. The implicit cast is necessary because sometimes you may find yourself mixing types. For example, if you mix a integer and a double, what'll happen is the compiler has to decide what the result is going to be. Let me give you an example. This is a simple one. If I do 5 plus 2.0, let's do division. 2.0. Okay. At that point, the compiler is looking at both values, and it looks like the 5, and it says, well, this value does not have any floating point attached to it. Then it looks at 2.0, and it says, well, this is a floating point value, so I'm going to treat it as a floating point value because of the 2.0. But then it says, I need to decide what the result is going to be between an integer, the integer is 5, right, and the floating point number 2.0. The compiler at this point is going to make the necessary implicit cast. Okay, now how does it decide this? It decides this by using something called an integral promotion. Again, it decides what it's going to cast it to by using an integral promotion. Okay, let's pause for a second so you can look that up and kind of digest what I'm trying to say. But let me pause for a second. Okay, what I wanted to do is I wanted to search the slide lesson that shows the promotions. I didn't want to waste time just recording how I search. As I mentioned before, the compiler decides at the point of implicit casting what the result will be once the expression is evaluated. Whenever there is a mix of types, it has to do something called promotions, more precisely called integral promotions. If you look at my slide, it shows you what each data type will be promoted to. In this particular slide, it tells you that if you have a char, it's always going to be promoted to an int. If you have a short, it's also going to be promoted to an int in an expression automatically. Okay? If I go on the next slide, you see that an int is lower than a double. Okay? So what happens is the double rules in the land of data types. Well, actually, long double rules. Double is probably second in command. What does that mean to you? Well, it means that if you mix the types with a double and an int in an expression, and you're guessing, well, what is the result going to be? The result is going to be in a double. Okay? So if when I do 5 divided by 2.0, okay, my result is going to be what? Who wins? An integer or a double? If we look at our chart and we fight the integer versus the double, you see that the double is on the top of the hierarchy chain, so that means the double will win. So what are you expecting for the output to be? Well, let's see. If you run this, that's right. Because an integer versus a double, again, the double is higher in the hierarchy, and the double will win and prevail during this. So you'll have your remainder intact. Okay? So what happens when you mix a float and an int? Same thing. If you mix a float and an int in an expression, the float is on the top of the hierarchy chain, so the float will win. Okay? Take a minute to do a couple of examples yourself and try and mix these data types and see what the answer is. Okay? The outcome of the expression will be the higher data type. Okay, and just like in this case, 5 divided by 2.0 gave you a floating point result, which is a double. Okay, let me give you another example. If I don't mix data types and I say int versus int, they're both obviously two ints, so it's going to be an integer result. So if I close this and I compile, it's going to give me a 2. Okay, that's what the compiler does when it does an implicit cast. It uses this hierarchy to decide what the output result will be. Okay, now there are times when you can cast explicitly on command. For example, let me take this out, and let's say I had int I my val 1 equals 5, I your val 2 equals 2. If I do a cout I my val 1 divided by I your value 2, you know that an int divided by an int, if you look at the implicit casting rules, it's going to do int, right? Because they're both the same data type. So let's compile and run this, and you're going to get 2. That makes sense so far. But suppose that for this particular moment, you want to get a decimal floating point result. You want to get a decimal floating point result. So you want to get 2.5. You don't want to get the 2. This is where explicit casting comes in. With explicit casting, you can cast it to a data type, in this particular case, a double, and your result will be a double. So how do I do that? Easy. You just put the data type that you want to cast it to in parentheses. Okay. If I do that, that means my IMyValue1 is cast into a double. Okay. IMyValue1 is cast into a double. So if I do execute, compile, and run, see that? 2.5. Because at that particular moment, I've put a cast to double to my IMyVal1. Okay. But again, it's at the moment of casting, so it's a temporary cast. It's not permanent. If I did this, my variable is still an integer. Okay, so if I do this, if I do compile and run, you have 2.5, and then you have my value, which is 5, which is still an integer. The data type only changes at the point of the expression execution of the cast. It does not change permanently. You have to realize that, because the typecast operator is only temporary. Okay. The next unary operator is the size of operator. The size of operator tells you the number of bytes that are allocated or necessary to allocate of the operand. So for example, if I want to find out what the size of an int is, easy. And again, this returns the number of bytes, okay? Number of bytes. Size of an int will give me 4, because there's 4 bytes in an int. If you always wanted to know how much space was in a double, how many bytes were in a double, it's 8 bytes in a double. Okay. Now, what if I declare a character string array called name of 20 bytes? What would that return? Let's see. Take a guess before I compile. 20. That's right, because my character string array, I allocated 20 bytes to it. Okay? And what the size of is going to return whatever I've allocated here, not the built-in one. Now, also, remember, if you want to take a look at the size of a literal, right, the way the compiler treats it, you can do that too. I can say, what's the size of the literal 295? How is the compiler treating that? How much space is a compiler allocating to the numeric literal of 295? And we can look. We can say compile and run. It uses a 4 bytes. It looks like it converts it into an integer literal. That's what it looks like. Okay? That's what it looks like. You can also get the size of a variable, how many bytes have been allocated for it, as we did with the char. So my val, if I compile and run, let me close this, 4 bytes. Okay, now here's a cool thing, alright? Remember how we were talking about implicit casting? Okay, implicit casting. If I do 3 times 4.0, okay, what's going to happen is it's first going to evaluate what's the result of that expression. Okay. Then, but before it does that, it has to decide who wins the battle, right? So who wins the battle between a double and an integer? A double. And how many bytes in a double? It would be 8. So I'm expecting this to to print out 8 because what's the compiler saying is the size of this. What the compiler is going to do is say, as a result of the integral promotion and double being the all-time king and ruler of integer, I'm going to return an 8 because that's how much space I need to store this result. And there it is, 8. Okay, so size of is very useful, especially when you're reading input. It'll tell you how many bytes to read on the buffer. Okay. Okay, so that's the unary operators so far. The next one is a little more involved, and you're going to see it throughout C++. You're going to see it throughout your programming career. So I suggest that you really pay attention to the lesson for the increment and decrement. Let me pause a little here, and I'm going to continue doing this lesson. It's a little bit late, so I'm not going to finish it now. I will continue doing this lesson tomorrow, and hopefully if you have any questions, then obviously I will answer them through email after the lesson is done. But I need to really think about how I'm going to present this to you guys so that you understand the logic that goes on into the increment and decrement operators. So I will pause now, and then I'll continue in a bit. Resuming with the incrementer and decrement operator, and we're over here. The increment operator will increase the operand by 1, and the decrement operator will decrease the operand by 1. And you're going to be using this a lot in for loops, any type of loops that, for example, any type of iterations that you're going to be using with C++ as you go on through the semester. And there's 2 types of increments, and same goes for decrements, but we'll go over increments because the logic is the same. You're either increasing by 1 or decreasing by 1. But there's 2 forms. There's a prefix and a postfix. So we do prefix or postfix. Okay. If I declare int I my val equal to 5, and suppose I do the following, I my val 1, and I do a prefix increment, and then I print this out, what's going to happen is the value of I my val will increment by 1. So if I run this, originally it's 5, the output should show up as 6. And there you go. Okay. If I do a postfix increment, the way it looks is I my val 1 plus plus, and then I do a cout, same variable, and I execute, compile, and run. And there you go, it incremented by 1. So what happened, let me explain what happened here. You have the variable called I my val 1, which is equal to 5. You did a prefix form increment. This will have the value of 6. Same postfix increment. So now 6 will become 7, and that's why you have an output as 6 and 7. Okay. There's really no difference between a prefix and a postfix outcome unless you're using expressions combined with a prefix and a postfix, and I'll show you what I mean by that. Let me exit out of this. The prefix increment will result in a side effect. The postfix increment will not result in a side effect. I'm sorry, the postfix will result in a side effect. The prefix will not result in a side effect. And what do I mean by a side effect? It means that a value after the expression is executed the value of the variable that's being incremented using the postfix will change its value after the expression. Let me show you an example so you understand where you're following through, okay? So we're just going to kill this. If I have your value 5 to, let's change this to 7 so I can follow the examples. And then I have answer, which is equal to 0. Okay. Answer is equal to plus plus I my val 1 times your value. Okay, now let me explain what happens here. Because this is a prefix increment and it's in prefix form, the side effect of this is I my val is going to change within the expression. I my val will change within the expression. I my val will become 6, and 6 times 7, because your value, which is actually, let me do I your value 2. Okay, and then let me print out answer. I my val will increment by 1. This will be 6 times 7, which will give you 42. If I compile and run, there you go. That's using a prefix increment. If I did a postfix increment, this means the side effect will occur after the execution of this expression. This will stay as 5. Hence, you'll have 5 times 7, and your answer will be 35, as we see here. So your answer is 35. Did you get that? Let me go over it one more time. With a prefix increment, the side effect will happen right on the expression. It'll take this value and increment it by 1 right on the expression. Take 5 plus plus would be 6. 6 times 7 would give you 42. So if I run this, gives you 42. Okay. Whereas if I do a postfix increment, the side effect won't occur till after the execution of this expression. Hence, I'll have 5 times 7, which is 35, and my answer will be 35. Okay? Now, the other thing I want you to realize is, no matter what you do with a postfix or a prefix, you're going to change the value of your variable, no matter what, regardless. The only difference is if you use a prefix, the value of the variable will change within the expression, and if you use a postfix, it'll change after the execution of the expression. Okay. Again, the rules are the same because you're always increasing or incrementing the variable by 1 when you're doing an increment. The only difference is how you're doing it in terms of the form. You're either doing a prefix form or you're doing a postfix form. Okay? Let me pause and then we'll start on the math library functions. Let me continue with the math library functions. Now, you're probably asking what's a function? Well, a function is just like a mini program where it'll perform one task. And you can call a function or invoke a function, but in order for you to execute a built-in function, you have to know what library you're looking at, so that you are able to use the functions from that library. In this C++ course, you're not going to be writing functions, you will be only calling functions. In C++2, you will be writing your own functions within your own program. And it makes life a lot easier when you are able to write your own functions. Let me go over the CMath function library, and I will go over a couple of the functions that it includes so that you can do math operations with your C++ program. The first thing you need to do is you need to include the CMath library. You would do #include CMath. Let's take a look at how it works. You have a function called POW, which is basically a power function. It returns the outcome of the base value raised to the power. In this particular case, this IMY value is 5, and you would read this as 5 squared. This is your base, and this is your exponent. Now, with functions, you have to recognize what kind of parameters you need to pass in so that they work properly. This is a one parameter, and this is another parameter. We're passing an integer and an integer. Now, the problem with some functions is that they're very tight on data types that you pass in. So if you notice, if I try and compile this, I'm going to get an error. Why? Because the power function accepts two floating point numbers, either a double or a float. What we do then in this case is, remember typecasting? So what I'll do is I'll typecast this to double, and I'll just make this a literal. Now, this is going to give me 5 squared, which is really 25. Now, let me do that. And there it is, 25. Again, very easy. This is the base, and this is the exponent. The base has to be a floating point number, and so does the exponent. Okay? And then what I did is, because I'm passing an int, I just cast it to a double, and I was able to call the POW function. So a little bit of an exercise. Try and do this equation, 2 times a value, and I'm going to say squared, times value 2 to the third power. Okay? Try and do it while you follow along. I'll give you about 2 minutes. So I will pause this. Did you figure it out? This is it. So what I did is 2 times value 1 squared. Take the base, which is my value, to the second power, and then I need to multiply that by value 2, so I use this, to the third power. So value 2 to the third power. The thing you have to be careful is, I had to construct this with my parentheses, so this covers this, and then you have to be careful with your power parentheses. Okay? Make sure you try it. You see it on the screen. You can write that down and practice. Okay. The next function that we're going to use in CMath is called the square root, and that's SQRT. If I say SQRT, and then I can say the square root of 9. Okay. So let me compile and run. Square root of 9 is 3. Okay. So what this will return is a square root of this operand, and this operand can be an expression, so I can do the result of 4 times 5 divided by 6 times my variable. So you can do any number of combinations here, and then it'll take the square root of this whole expression. Let me execute that, and there you go. It gives me a square root of 3.8298, whatever that value is. Okay, this is how you can do a quadratic equation, right? If you try and do a quadratic equation, you can with C++. You can just plug in the numbers and take the square root of your expression. It's very easy. Now, can you combine this with the POW function? You can. You can go back and forth. I can do POW of 5.0 to 2.0. So what it'll do is it's gonna square my 5. 5 squared is 25, and then I'm gonna get the square root back, which is gonna be 5. So if I do that, it's gonna give me 5. And then vice versa. I can put a power function. I can call the power function, and within the power function, I can call my square root function as a base to whatever power I want. So 3.0. Right? So what's happening here is it's going to evaluate this first. So the square root of 25 is 5. 5 to the third power is going to be 125. So if I execute that, oops, power, let's see what's going on here. So power of, let's see, main expected before token. There's an issue here with the way I'm calling it. Oh, I don't need this extra parentheses. So again, square root of 25, which is 5. 5 to the third power is 125. So if I do that, there you go, 125. Pretty easy. It'll do all the math for you. Another function we can use is called an absolute function, which will take the absolute value of a number. For example, if I do CL ABS of, let's do I your value, and let's make this negative. If I compile and run, it'll take the absolute value of it. Okay, and again, with this, you can take the absolute value of an expression. So I can say I, my val, 1 times negative 1, right? So it's going to evaluate this first and then take the absolute value after. So if I do that, it's going to give me 5, because I'm multiplying 5 times negative 1, which is going to give me negative 5. And the absolute value of negative 5 is 5. Okay? Next, we're going to go into the string length, string functions, string defined functions for char. And I'd just like to pause here for a second so that you can go over this yourself while I get everything ready, so that we can use the 3 functions that I'm going to go over, which is strlen, strcpy, and strcat, which stands for string concatenate. I'm resuming to continue our lesson with the string functions. With the string functions, you have the ability to get the size of a string, to copy one string to another, and also concatenate 2 strings together. Because if you've tried it, you can't do an assignment statement using the char character string array after it's been declared. So for example, if I try to do this over here, and I try to assign the value of hello to CNAME, the compiler would tell me that that's not allowed. Can't do that. What I could do is I can initialize it here at the same time that I declare it, and that won't cause any error. But what if I want to change the value of CNAME after declaration, as in reading a value in? Or I may just want to change it some other way and assign it another value. And I'll show you that with the other functions. But let's go over the function called strlen, which is short for string length. The strlen is going to return the size of the actual occupied bytes in your character array. And what it needs as an argument or parameter, and this is an argument, is a character array that you're trying to test. The other important point about this function is that this will return an integer because it returns the actual length of the occupied bytes of your character string. Let's test this. So if I execute and run this, and let me enter my name. So I will enter Alex space Louis. And as you see, I'm using the getline. What this is going to do is it's going to call the strlen, and it's going to return the size of the occupied bytes in my character array. My character array has 25 bytes allocated, but after I enter this input in, it's going to have 1, 2, 3, 4, 5, 6, 7, 8 bytes that are allocated, plus the null terminator, right? Because for every character string, you have to make room for the null terminator. But the strlen will not account for the null terminator. So you have 1, 2, 3, 4, 5, 6, 7, 8. It only returns the size of your occupied bytes, that you actually have the size. It just assumes that you know that the 9th byte is going to be the null terminator. So out of those 25 bytes in your character array, 8 bytes are occupied after I called the cin.getline. Okay? The other function that we can use is the strcpy. As I showed you before, you can't do this. You can't do that, right? It gives me a compiler error. So if I try to compile that, it says no. But what I can do, let me just comment this out, is the equivalent of this is using strcpy, and the first parameter has to be your string that you're copying to, and the string to be copied is the second parameter. So if I do the following, this should print out hello. So if I do that, it's going to print out hello. Okay, so basically this is the equivalent of the assignment of cname equals hello. Okay, and this doesn't have to be a literal string. This could be another variable. Okay, so if I create another character string, call it c long name 30, and I say, okay, I want you to copy into c long name CIS165, and I also want you to copy c long name into cname. Okay, so let's trace through this. This will copy this string into c long name, and then this will copy whatever's in c long name into cname. And after the execution of this statement, you have CIS165 in c long name, and then you're taking that value and copying it into cname. So I can do a literal here, like I did here, or I can do a variable, like I did here. This parameter has to always be a variable. It cannot be a literal. And again, a literal would be something like this. Okay, you have to have a variable. You have to have something that occupies space, that you've allocated space for in memory. Okay, so if I execute and compile and run, you have CIS165 in cname. So that's strcpy. So now you can assign strings to your character string arrays. Okay, so let me do that. You may sometimes want to concatenate two strings, and you can do that with the function called strcat. If you do the following, so I'm going to combine it here. So I'm going to say this is strcpy into cname John Doe Okay, and then I'm going to use the strcat function to say cname. I'll explain to you how this works. What this is going to do is, as we showed before, this is going to copy John Doe into cname. So cname now has, so I can say cname is equal to John Doe. And then this is going to concatenate whatever is in cname with comma junior. And it does an append. It does an append. So what you would do is, you would say, this would be, the result would be, cname would be, let's do the following, is equal to John Doe, comma, junior. Okay, so if I print the cname out, let's do compile and run. So there it is, John Doe, junior. Okay. So with the concatenate, with strcat, you can concatenate two strings together, and it will append from the second string to the first. Okay? From the second string to the first. Now, the other thing you can do is with strcat, I can concatenate with a variable. So I can say cname, actually clongname Washington. So I'm copying the string of Washington into clongname, and then I'm going to concatenate these together. Okay. So I'll execute, compile, and run. So I say John Doe, Washington. Why? Let's step through this. This copied Washington into clongname. Okay, so let's write that down. Clongname is equal to space Washington. Okay. Then we said copy John Doe into cname. So cname is equal to John Doe. And this said concatenate whatever is in clongname and add it to cname. So now you'll have John Doe, Washington, which is what the output represents. John Doe, Washington. Okay. So the second parameter could be a variable or a string literal, but the first parameter, okay, the first parameter has to be a variable. Okay, it has to be a variable. But the second parameter is either a variable or a string literal. Okay? Okay, so that concludes our lesson for week 5. What you need to do is, under Moodle, if you go back to Moodle, there is a, and I'm going to actually show this. Actually, I have to log in now, so let me go back, because it probably logged me out. So if I say, hey Louis, log in. So let me go into my course. Turn it on. Under week 5, you're going to see a math operator review exercise. I suggest you go over that without looking at the solutions. and try it yourself. Okay, try it yourself. Try doing it yourself and put it on the actual compiler. Okay, then answer the questions below and see if you can do that yourself. Okay, I would also read the pages on top so you get familiar with, you can kind of regurgitate that information again to yourself and reinforce what you've learned. Okay, and if you have any questions, please let me know. I'm always available by email, and some students I've actually spoken to on the phone. If you need to get in contact with me, just send me an email and I will set up a time to call you, or you can call me. Okay? So take care. I will talk to you in week 6, and I hope that this lesson has been helpful. Take care.